Hi, in this video we want to look at Python's iteration structures. Very often when you're writing a program, you're going to have a batch of code that you want executed over and over and over again. So to do this, we have two iteration structures. We'll start by looking at the while. So this diagram represents the flow of some programs. So you may have instructions here coming along. So the program starts here. You have instructions along here. And then you reach a conditional branch. Now, in this case, since it's a loop we want to create, we're not going to use the if keyword that we looked at earlier. We'll be using the while. So this while expression will have a predicate, and if the predicate is true, this code here will be executed, and then the predicate will be checked again, and if it's still true, this code will be executed. And this code will always be executed as long as this predicate is evaluated as true. The moment it's evaluated as false, then the program continues. So you could have instructions here. So let's look at an example. Here is a very basic example. X is initialized with the value 0, and as long as x is less than 9, that is 0 through 8, this code will be printed. Notice in here we have a function that increments x. So your code must always have a way for this predicate to become false eventually. If that doesn't happen, if this always remains true, the loop will never be exited, and your program will just be caught in an interminable loop. So it'll print the value of x. When it first enters in here, the value of x will be 0, and then it'll be 1 the next time. Eventually it will reach 9, but when it reaches 9, this will evaluate to false, and so this will never be executed. So here is the result: 0, 1, 2, 3, right up to 8, and then goodbye. So this loop is said to be counter controlled. So this x is acting as a counter. In fact, very often when I write programs, instead of calling this x, I prefer to literally call it a counter, because that is what it's being used for. So here I'm just printing the value of the counter. In a real program, you will be doing something more interesting in here, and the counter will just be used to determine, well, how many times it gets done. So there are two ways of controlling an iteration, either using a counter or using what is called a sentinel, and we'll look at that shortly. Of course, a counter doesn't have to count up, it can also count down. So here we start at 10, and then whenever we come into this loop, the counter is decremented, and of course this batch of code will always be executed as long as this is true. In other words, as long as the counter is greater than 0. Notice, because it is only going to be true as long as the counter is greater than 0, this will never print 0. So think about what change you would need to make to this code in order to get it to print the 0 also. Or you could also make it print, let's say, from 10 to 5 or whatever. So you need to be able to control these counters. So let's run it. And so we see here coming down 10, 9, 8 to 1, and then goodbye. I want to reiterate how important it is to make sure that when your code executes, there is some mechanism whereby this predicate can become false. Let's suppose you make the mistake and you put +1 here. What's going to happen? Well, it starts out at 10 and it will go up to 11, 12, 13, and it'll always be greater than 0. So let's run this and see what happens. And so that's what happens. So this is what a program caught in an interminable loop looks like. Now, there are going to be times when there is nothing to show that you are caught in such a loop. So for example, so notice you can kill the program by simply closing the window. Let's suppose I didn't have this print statement here. So I put a comment. A comment is used normally to put some information to help the person reading the code understand what's going on. But you can also use a comment to make sure that to make the computer ignore a command. So for right now, I just wanted to ignore this command, so I turned it into a comment. So the interpreter will always ignore comments. So let's run this now and see what we get. The fact that I don't see the command prompt is what lets me know that this program is running. I try and close the window, see, program is running. Okay, so now let's look at sentinel control. What this program will do is print the value associated with x. It's initially assigned the number 5, and it will do this as long as that value x is less than 20. Now this may seem like a counter situation, but it is not, because the value x inside this block is randomly given a value between 1 and 22. So let's suppose the program starts off, x is given a value 5. It's less than 20, it comes in here, it prints that x is 5, and then x is given a random value. Let's suppose it's given 3. Well then, it'll come back here and okay, it's still less than 20, it'll print 3. Let's suppose here now it's given the value 15. It'll come back here, it's still less than 20, and it'll print 15. And it will continue to do this until it's given the value, a value larger than 20, in which case then this will evaluate to false and this block will not be entered. To keep track of how many times the block was entered, I have this variable here, numHits, and so when I'm finished, notice this will always be entered at least once because we start off with 5. Now if we had started here with a random value, well, sometimes you would enter and sometimes we wouldn't. So when it is finished with this block, it'll come here and say the loop was executed, and this is where we use numHits. Notice we have to change it to a string so we can add it to this string here, the string, and just to see what the last value of x was, the value that made this evaluate to false, we print it here. So let's run this. So notice it only ran one time. In other words, the loop entered with the 5 and immediately x was given a value that was not less than 20. Notice this will only be true if the value is less than 20. So if it's 20, this will be false. Notice this time it ran 20 times. So when it entered at 5, and then it was given 19, 13, and as long as it's given a value less than 20, the loop will be entered again. And so finally it was given 22, and so it exited. So it's 20 times. This time only 9 times. So this is an example of sentinel control. This block will run, this loop will run until some condition is met, but the program doesn't know exactly when that will be. In the case of the counter, the program knows it's going to do the loop so many times. Okay, so let's look at one more. In this case, we have a program that's going to ask you to guess a number, and it'll keep giving you chances until you get the correct answer. So the program starts off by assigning a random integer to secret number, and then you're asked to make a guess. And of course your guess will be a string, and so it's converted to an integer and assigned to this variable. And then as long as your guess is not equal to this secret number, this is the not here, notice the not here, you're going to be asked to guess again. And we'll keep track of the number of tries. If you get it right the first time, you will not enter this block because this will be true and therefore all of this will be false, and this is the predicate that determines whether or not you enter this block. So if you get it right, you don't enter this block, and so you guess the answer in only one try, and so it prints you took this number of tries. So let's run this and see what it looks like. Since it's 1 to 10, I'll just try them 1, 2, 3 like that. So I'll try 1, didn't work, I'll try 2, didn't work, try 3, try 4, wow, try 5, try 6, and finally it took me 6 tries. So once again we're using sentinel control. The program doesn't know how many times this loop will be entered. Okay, so far I think we have had a pretty decent introduction to iteration in Python, and before we close this video I want to take a look at nested loops. Now let's suppose a program starts here, and this is a block of code, it does some instructions, and then it reaches this loop. And so if the condition is true, then there's a loop, does a few instructions, but instead of just going back and testing the condition again, it encounters another loop. And so now, assuming the condition tests true, we come in here, and well, we go around this loop as many times as is necessary for the condition to become false. When it becomes false, we come out here, and notice the condition is tested again. If it's still true, we come back in here. These instructions get executed, we come here. Assuming this is true again, we go around this loop, and then when the condition tests false, we come out here. And so we come here, go around and around and around. So we are going around 2 loops, an outer loop and an inner loop. Eventually, there will come a time when, on arriving here, this condition tests false, in which case then the program will continue. There may be some more instructions here, and then the program ends here. Again, we're talking about very small programs. This structure could be part of a very large program, but we're not getting into that quite yet. So where would you see something like this? Well, the need to do nested loops pops up a lot. So this is something you really need to get. Theoretically, we could have a loop inside here and then another one, and have a very deeply nested set of loops. But normally we just have two. We'll see lots of examples where we need this later on. For right now, let's just make up a very simple problem. Suppose you want to write numbers like, say, 51, let's say starting at 50, 50, 51, 52, and so on until you reach 59. But then you want to print 40, 41, 42, 43 until you reach 49. And then you want to print 30, 31, and so on. And let's say you want to do this until you reach 39. Well, notice what we have here. We have a number, we have these numbers decrementing, 5, then 4, then 3. Well, these numbers are incrementing 0, 1 to 9, then 0, 1 to 9. So we could put this increment 0 to 9, 0 to 9, 0 to 9 in this inner loop, and this decrement 5, 4, 3 in this outer loop. So when it's 5, it'll come in here and it'll be 5, 0, 5, 1, 5, 2 until it reaches 5, 9. Then it'll be 4, and then it'll be 4, 0, 4, 1, 4, 2, and so on. So let's see how we can implement this. Okay, so we start off by initializing the two counters. Now these counters will be used to form the numbers themselves. So we're going to start at 5, 0, then go up to 59, and then go down to 40, and so on. As long as the outer counter is greater than 2. So it's going to go from 5, 4, and then 3. Right? And so every time we enter this loop, the outer will be decremented. Obviously, the first time we get here, outer is going to be worth 5. And so we'll enter here, and we'll take that 5 and get a string version of it and assign it to this number. Then, of course, we decrement this. Then we enter the second loop, and we ask, well, is inner less than 10? And of course it is. And then as long as inner is less than 10, we'll stay in here. So what do we do in here? Well, we concatenate this number, which is going to be in a string format, with this one, which we need to convert to a string. And so the first time we get here, this will be 50, and then this will be incremented. This will still be less than 10, so it'll become 51. So it'll concatenate 5 and 1, then concatenate 5 and 2, and every time it prints the number. Of course, this will eventually reach 10, in which case then this will be false, and it won't enter here. It'll come here and we reset. So this is very important. Students often forget to do this. We need to reset this inner counter here. So when we get here, this will now be what? 4. So we still come in here. We get a string version of 4, decrement it, then come in here, and we do the same thing. 4, 1, 4, 2, 4, 0, 4, 1, 4, 2. Remember, inner row is reset to 0. 4, 0, 4, 1, 4, 2. If we didn't reset this, we wouldn't come back in here again. So let's run it. And there you have it. 50, 51, coming up to 59, then 40, 41, up to 49, 30, up to 39. So there. So that brings us to the end of this introduction to Python. Remember, you need to read your assigned textbook and do the examples that you are given in class to do. Anyway, bye for now.